Alright, so we're going to continue in section 11.2. Now we're going to talk about triangles and quadrilaterals. So we've talked about congruency a little bit. We've talked about equal angular, equilateral, and some of those pieces of terminology you have to know before you can really get into, especially talking about quadrilaterals. And so as we continue here, we're going to spend this video talking about triangles and quadrilaterals. So triangles, really you could have three main types that we'll talk about in this class. We have a right triangle, and you can see the example there to the right. It is a triangle that has a right angle. Now, notice that the definition says specifically one right angle. Well, if it has more than one right angle, it's not a triangle. And so that should be self-explanatory, but we do specify that it does have to have one right angle. If it had two right angles, then again, it's not a triangle. And we know what a right triangle looks like. You've dealt with that quite a bit. You know what right angles are. Again, we've talked about that. And so hopefully identifying a right triangle is not a huge problem. The next term or next type of triangle that we could see is what we call an acute triangle. So again, this is something you've seen for a long time. My kids' teachers always talk about, when they talk about acute angles, they talk about, oh, that little bitty cute angle. Well, same idea here, but an acute triangle is a triangle that has three acute angles. So you can see that this angle, and this angle are all less than 90 degrees. And so because of that, it is an acute triangle. So again, all the angles have to be acute for it to be an acute triangle, because every triangle is going to have at least two acute angles. It just depends on what the other one, what the third one is. And so if all three of them are acute, then the triangle is considered to be an acute triangle. And then the next one is what we call an obtuse triangle. This is a triangle containing one obtuse angle. And again, we specify one, but again, if it's got more than one, it's not a triangle anymore. And so you can see in this case, this angle is considered to be obtuse. Now, we could also have triangles described based off their side lengths. So we can describe them based on their angles. We can also describe them based on their side lengths. So if a triangle has no sides that are congruent, like in this first example, we consider it to be a scalene triangle. Again, that just indicates no side lengths are the same. We also could have what we consider to be isosceles triangles, where at least two sides are congruent. And notice the phrase "at least." That's an important phrase here, because you could have all three sides be the same length, and it still be considered isosceles. If all three are the same length, we actually could call it equilateral, like in this third example, but it's also considered to be isosceles as well. And so that's one that falls under both categories of isosceles and equilateral. And so as we talk about quadrilaterals, we have several different types of quadrilaterals that we need to identify. So we know a quadrilateral is a figure that has four sides. And if it is a trapezoid, it has at least one pair of parallel sides. So in this case, this side and this side would be considered parallel. Now, if we are saying that side lengths are parallel, we will use a little arrowhead symbol like I've done here. If there happen to be two sets, then we'll put two sets of arrowheads, showing that those two sides are parallel and there's also another set. But in this case, we use just the one, showing that the top side and the bottom side both are parallel. So trapezoid has at least one set of parallel sides. Now, another type of quadrilateral we could have is what we call a kite. Now, you know what a kite looks like. I would assume most everybody has flown a kite before at some point. If I were teaching this in an elementary school class, or even in a high school class, if you're teaching like a high school geometry, I would do a project where I would have my students make kites. Now, obviously, I'm not going to see you in person again this semester, so we're not going to do that in class. But that would be something that could be beneficial. Let them be creative, let them design a kite, but stipulate that it has to be a kite shape. And so a kite, the shape is defined as having two adjacent sides that are congruent with the other two sides also congruent. So for example, this side and this side are adjacent because they're side by side, and they're the same length. That also means that this side and this side are also the same length. Okay, so two sets of adjacent sides that are congruent is how we define a kite. And again, you probably know kind of in your mind what that looks like, but as you can see here, we do have an example. Now, another term that we have, or another kind of quadrilateral we could have, is what we call an isosceles trapezoid. Now, notice in our definition it says a trapezoid with congruent base angles. These angles at the bottom, this angle and this angle, are considered to be the base angles. When those base angles are congruent, what happens is these side lengths end up being congruent as well. Okay, and we could go into details about why that works and how that works and kind of prove that. We're not doing that for this class, but understand that an isosceles trapezoid, just like an isosceles triangle, is going to have two side lengths that are the same, that are congruent. Okay, and so it's because the base angles at the bottom are congruent, but that forces those side lengths, and that's where the word isosceles really comes from. And again, later we may talk about side lengths and angle measurements and how they all relate to each other, because there is a relation. But for now, we're not really going to focus on that. Again, we're introducing geometry at this point. Our next quadrilateral is what we call a parallelogram. This is a quadrilateral that has each pair of opposite sides being parallel. So in a parallelogram, you would have those two sides that are parallel, and then also these two sides that are parallel. And so you can probably think of some various shapes, various quadrilaterals that kind of fall into that. A parallelogram could be a number of different shapes as well. And so we'll talk more about all of that in just a minute. And the next one is what we call a rectangle. You know what a rectangle looks like. And if you'll notice that the definition says it's a parallelogram with a right angle. Well, again, based on how sides and angles relate, if one angle in a parallelogram is 90 degrees, it means that every other angle is also 90 degrees. And again, we're not going to prove that. We're not going to get into the details of why that works. But just understanding that every angle is 90 degrees in a rectangle is important. We don't say that in the definition because being a parallelogram and only having one right angle is sufficient. But typically we think about a rectangle as having 4 90-degree angles. And then we also know about these two probably. A rhombus, which we mentioned a little while ago, is a parallelogram with two adjacent sides that are congruent. So again, based on that definition, it doesn't really give us the full picture, especially from an elementary level. A rhombus is going to have every side length be the same. That's really the key. It's not a square necessarily. Could be, but it's not necessarily, because you can see the angle measurements here are not going to be 90 degrees, but every side length is the same. And so it's going to be a quadrilateral with each side being congruent. And then we get to a square, which really kind of is really most of these that we've talked about. It's a rectangle that has two adjacent sides being congruent. Again, we know what a square looks like. It has every angle is 90 degrees and every side length is the same. That definition, again, doesn't really give us the full picture. It's assuming that you know a lot about parallelograms and rectangles and kind of how all that works together. And we haven't really gotten into all of that yet. So you may want to think about the square as being all side lengths the same and all angle measurements the same, specifically 90 degrees. Now, it's a lot of stuff. And so we can kind of look at our polygons, especially triangles and quadrilaterals, in this way. And this may be somewhat confusing, so hang with me here. When we talk about these two types of polygons, we could have a triangle, we could have a quadrilateral. If we have a triangle, it could be scalene, it could be isosceles. If it is scalene, that's it. It can't be anything else. If it is isosceles, it has at least two sides that are the same. But if it's isosceles, it also could be equilateral. So in other words, if a triangle is equilateral, then it is also isosceles. It is also obviously a triangle. It is obviously also a polygon. So you're going to have this hierarchy of, well, equilateral kind of falls into multiple groups. Now, the other option with a polygon is that it might be a quadrilateral. And it might be just a random four-sided shape with nothing the same, nothing parallel, any of those things. But it could be that the quadrilateral is a kite, or it could be a trapezoid. It can't be both. Based on their definitions, it can't be both. So a trapezoid has one set of parallel sides. The kite has adjacent sides that are congruent. Two sets of adjacent sides that are congruent. So it's not possible to be a kite and a trapezoid. But if it is a kite, it could possibly be a rhombus. And if it is a rhombus, then it could possibly be a square. And so again, if you think about the square, well, it would be a rhombus. It would also be considered a kite. It also is a quadrilateral. It also is a polygon. But we could have a trapezoid too. And so our trapezoid, again, by definition, has one set of parallel sides. Well, that trapezoid could be a parallelogram. And if it's a parallelogram, it could be a rhombus. Or it could be a rectangle. And if it's a square, then it's all of that. But our trapezoid could also be an isosceles trapezoid, where it has two side lengths that are the same. And it's possible that it could be an isosceles trapezoid and also be a rectangle. And it could also be a rectangle and also be a square. And so again, if you think about this, a square is also a rectangle. And a rectangle is an isosceles trapezoid. And an isosceles trapezoid is obviously a trapezoid. A trapezoid is a quadrilateral. Quadrilateral, again, is a polygon. This rectangle, though, is also a parallelogram. And a parallelogram is also a trapezoid. And the trapezoid, again, is quadrilateral. Quadrilateral, again, is polygon. And so you've got all of these shapes that are working together. And I think the quadrilateral especially, you've got to get your mind wrapped around understanding what each of these are and how they all fit together. So if I ask you to tell me, well, what kind of shape is a square? Well, you would need to be able to tell me that it's a rhombus, and it's a rectangle, and it's a parallelogram, and it's a kite, and it's an isosceles trapezoid, it's a trapezoid, it's a quadrilateral, and it's a polygon. Or if I say, well, what's a rectangle? What does it fall into? Well, it's a parallelogram and isosceles trapezoid. which is also a trapezoid, which is also a quadrilateral, which is also a polygon. And so, again, you may have to study on this a little bit, and you may have additional questions that I need to answer. If you do, please email me, let me know. I'm sure there are probably questions that you have, and so I'll be glad to answer those. We will continue with line symmetry